Australia has some 33,000 route kilometres of open railway, with over 1/5 of that being in Australia's largest state, New South Wales. In the state's capital, Sydney, some 365 million passengers travel on Sydney Trains rail network every year.
1 million people utilise our system, our rail network each day. Approximately a quarter of them travel over the Harbour Bridge. So the significance there is that we're producing a more reliable, safe rail network for our travelling public to utilise.
The Sydney Harbour Bridge was completed in 1932. It has a deck that caters for 8 lanes of road traffic, 2 railway tracks, pedestrian footways and a cycle path. The bridge is a national icon and is the most recognised landmark in Australia and internationally. It has been classified as historic and is National Heritage listed. Although designed more than 90 years ago, the bridge has still not reached its loading capacity. And from the time it was built, when the rail track crossing the bridge needed maintenance, no rail profiling was ever carried out. Instead, rail was completely replaced. Rail replacement is a very costly and disruptive exercise that takes considerable planning, sometimes years in advance.
Other solutions that we have for rail profiling on any bridge, in particular the Sydney Harbour Bridge, would just be re-railing the actual track. Very expensive exercise. A lot of planning goes into that construction.
An alternative to re-railing is to profile the rail. One option for this is conventional rail grinding. Although extending the useful life of the rail, grinding has never been carried out on the bridge because it has been assessed as posing too high a risk to both safety and the environment. So rail grinding is not allowed on bridges. Grinding abrades the metal, spreading sparks, dust and particulate matter into the environment. Waste material is poorly contained and poses a risk to nearby people, vehicles, and the bridge itself where it is galvanised. There is also a risk of contaminating the waterway below and setting fire to wooden sleepers and other flammable parts of the bridge and its surrounding environment.
The Sydney Harbour Bridge is a transom bridge. All the sleepers are timber, the walkways are timber, there's a lot of timber up there. We really don't want to have anything that can risk basically catching on fire. Grinding, obviously, they do have mats, they do have suction systems, but yeah, they can't contain everything, so they can't go over waterways because they run the risk of dropping byproduct into the waterways. They can't go past car parks, that sort of thing, because you risk damaging the cars with those parks.
Recently, an Austrian company, Linmag, carried out fault finding and repairs to several states' rail networks. Linmag has successfully delivered projects in countries worldwide, including Ireland, Germany, Canada, Singapore and Australia. With its milling machines from Linsinger, the company that invented a breakthrough rail milling technology, Linmag has become a world leader in rail profiling by specialising in milling the rail instead of grinding it. Rail milling can significantly extend the rail life at a fraction of the cost of rail exchange. As well as the technical and environmental benefits, rail milling also provides considerable benefit for the rail network.
There's a lot of defects and surface affected rail is happening within the network, and milling is going to prolong the life of the rail by giving a nice smooth surface to the top of the rail.
Milling uses cutters to cut the metal instead of grinding it. It generates less heat and so does not affect the metallurgical structure of the rail. It has no sparks to cause damage to people, vehicles or the bridge. And there is close to zero risk of fire to the bridge's woodwork. Milling also provides a smoother surface finish that helps mitigate the rolling noise of passing trains, which benefits both nearby residents and provides a better ride experience for passengers.
Rail milling provides us with that opportunity to profile and prolong the life of the rail.
With all the timber sleepers, there is obviously the risk of fire, and that's why Sydney Trains is chosen as one of the few options they have. And to extend the rail life, they obviously want to treat the railhead and maintain that, and milling gives them the option to do that.
After 2 years of trialling the milling process, Sydney Trains, for the first time, entrusted Linmag to profile the rail track on the historical, heritage-listed Sydney Harbour Bridge through milling.
So first time ever event tonight with the rail milling machine on the Sydney Harbour Bridge. Obviously tonight we're trying to achieve something that's never been done before by undertaking some rail profiling with the milling machine. To to ensure we're meeting the Sydney trains and the Australian standards. The finish of the rail is quite extraordinary. We obviously have been rail grinding for a long time. Milling is new on the scene, and we've done a few trials before, but this is purely and simply because of the inability to grind on the Harbour Bridge.
Well, a major difference between milling and grinding is clean-up. We don't have any clean-up afterwards. Our machine stores everything we machine off internally. It's a different way to do it. We end up with a finer finish, and we can do bulk metal removal up to sort of 1.5 mil in a pass versus a grinder which can't get up that high really without putting a lot of heat in the rail. We don't put any heat in the rail at all. All the swarf actually takes the heat away, so we're not affecting the metallurgy of the steel at all.
Rail milling is a gentle rail treatment that completely removes damage and restores the full rail profile to meet standards. This creates an as-new rail condition, known as regenerative rail maintenance.
The window is fairly small, so we need to be very efficient. So the machine needs to first go on track in a very quick way, travel to the milling position, and then in this 2.5 hours we have time, we need to deliver a pass over the whole bridge. The machine works the same on rain, on snow, on hot weather, so it doesn't affect the process itself.
So we will get a picture on the screen where we can put our cursor on the rail ends, so we can move the units after to the position, and after one button the magic is happening.
Yeah, the team is a very experienced crew. They all come together. We have got partly Austrians, we have got local crew as well, so they obviously understand each other and they know what they're doing, are very experienced, and that's especially today very important to not get distracted by environmental aspects and to really focus on what their job is, and having this crew that definitely deliver on that.
Rail profiling typically is very difficult on the bridge, in particular a landmark like the Sydney Harbour Bridge. So by introducing rail milling, we've eliminated a lot of the risk, environmental risks and the like. And so by not having the need to re-rail, or not as often anyway, rail milling is the perfect alternative to providing that reliable, safe network for our travelling public to use.
Milling the Harbour Bridge is a significant and complex project for both Linmag and Sydney Trains. Its success required a collaborative planning and delivery approach to identify concerns, to address potential issues, and to develop an effective plan to overcome them.
So it's a great opportunity for us to show this technology on the bridge, and it's the first time it was ever been maintained, the railhead up on the Harbour Bridge, and it's great for Linmag to be this company chosen to do this job.
The milling project successfully profiled the rail to fully meet Australian standards, which has not only effectively extended the life of the existing rail, but has also made the network safer and more reliable. Now, the 250,000 passengers that cross the Sydney Harbour Bridge every day will experience less noise from passing trains and a superior ride.